Today, we are going to use 3 different methods to find the greatest common divisor or the greatest common factor of 16, 24, and 36. The first method is called prime factorization. Prime factorization is gathering all the prime numbers that are consisted of that one number, which is 16, 24, and 36. These are all the prime numbers that when multiplied make up 16. And the same for 24 and 36. After this, we find the prime numbers that they have in common. They all have 2 in common. We also find that they have another 2 in common. After this, there are no more common prime numbers. We then use 2 times 2 to get our common factor of 4. Using the Euclidean algorithm, we are going to use the greatest number in the set, which is 36, and the smallest number, which is 16. We use 36 and an equal sign. To the right of the 36, we're going to try and find what makes 36. We have to try and find a number that when multiplied to 16 will get you 36. However, there is no number to multiply to 16 that'll get you exactly 36. So the closest one without going over is 2. This is 32. You still have to add 4 in order to make the statement true. After this, you do the same process by moving the 16 to this side of the equal sign and moving 4 to where the 16 place was. So 4 times 4 is 16. You have to add 0 because there's nothing else you can add that will equal to 16 exactly. Once you hit 0 in this process, the number before that prime number is the GCF or the GCD. To check my work, I did the same thing. I used the same algorithm. However, I started with 36 and 24. After getting 12 as the greatest common factor or the greatest common divisor of 36 and 24, I then used that and 16 to start another algorithm. That's how we determined and how we checked that 4 was the right answer. In the last method, we are listing all the factors that make up 16. These factors are 2 numbers that equal 16 when multiplied. For example, 24, 1 times 24 is 24, 2 times 12 is 24, 3 times 8 is 24, and 4 times 6 is 24, and nothing else put together will equal 24. After you listed all of the factors of each of the 3 numbers, you are then going to circle the common factors, which is 1, 2, and 4. However, since you're finding the greatest common factor or the greatest common divisor, 4 is going to be your answer because that is the largest number here. The thing that the prime factorization and the listing factors have in common is that in the same way you're listing factors in the prime factorization. 2 times 2 is 4. 2 times 2 is also 4. So 4 times 4 is 16, and those are factors listed here. You can tell the same thing for 24 and 36. The difference between the Euclidean algorithm and these 3 factors is you are still using factors, however, they aren't to get the same result. And here, you are using a formula that can be derived from our example. The thing that all 3 of these have in common is the fact that they're all using factors So, for example, to check our work, we had to use 24 times 1, which is 2 factors, to make 24. And here, we had to use 12 times 2, which are 2 factors, to make 24. Here, we also had to use 16 times 2, which are factors, to make the closest number to get to 36. And this will conclude my video. Thank you.